You are awesome. Okay, starting, here we have name of the topic today, title of our notes is real numbers.
Oh, I put math. I'm not wrong.
It's not wrong. It is. Real numbers and properties. Today's date, you can put your date in there. It's the 6th. And today's class, wow, you can put your class period in there. So, it's a basic vocabulary lesson today. We're just associating terms with sets of numbers. So, most of this is review. Some of it might be new, but it's helpful in the start of a new semester of math to just do some refresher. So the first category of numbers we're talking about is the set of real numbers. And the symbol for that is the capital letter R with an extra vertical line. So I usually just draw 2 vertical lines, and then I make my R, and I don't cross it in the middle, just at the top. So that's the symbol for real numbers. It's nice and easy. I don't have to write out all of those letters, real numbers, just a little symbol. Nice and easy. So real numbers actually consist of several subcategories. The first one of those is irrational numbers. Can you read the definition for irrational numbers, please, Tyler?
Numbers in which the decimal form never terminates and does not repeat. Common examples are pi and non-perfect square roots.
Excellent, thank you. That's irrational numbers. In words, we'll look at some examples below in a second. Rational numbers, can you read that one for us, please, Brooke?
Numbers in which the decimal form either terminates or repeats. Rational numbers can always be written as a fraction, a/b, where a and b are integers.
Excellent, thank you. So rational numbers happen to have several subcategories as well. Underneath rational numbers, we have the subsets, integers. These curly braces here, we're going to become very familiar with those. Those braces actually mean the set of all numbers. So dot, dot, dot just means that set of numbers continues infinitely in the negative direction towards negative infinity. -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. So it continues endlessly in the positive direction as well. Whole numbers start at 0. They have a starting point. And again, they go on into the counting numbers from there to infinity. Natural numbers, the only difference between natural and whole, you see it?
No zero.
No zero. Natural numbers, no zero. That's it. So each one of these categories has a symbol to go with it. Some are more intuitive than others. So irrational numbers, the symbol that we use for irrational numbers is the capital letter P. And sometimes the capital letter I. So make sure you're filling all this in. I believe that the way that these notes are set up with the chart, and then we're going to do a Venn diagram, we've got the definition of words. You talk about different ways of learning one topic, it's right here.
So with the capital P and an I, or an I, since the I kind of like looks like the irrational symbol, is like, does the P mean anything specific, or is it just the signed letter?
I can't remember off the top of my head, but I'm guessing Latin. Let's follow up on. Let's circle back around to that. We'll Google it. So examples of irrational numbers, we talked about it already. So like pi, square root of 2, square root of 5, even something like the square root of 50. These are all irrational numbers. Rational numbers, R's already taken. So the next best thing we have is Q, obviously. Why Q? Here's why. This is how we can connect it. So if you think about rational numbers, can be written as a fraction, and Q, another name for a fraction, is a quotient. So think quotient. You might write that little thought bubble there, quotient for Q. So some examples would be 0.34. We can write that as a fraction as 34 over 100. Even the number 5, any natural number or whole number, can be written as a fraction over 1. And then, not to be confused with irrational number, if the number does repeat itself, it goes in this category, rational numbers. Next category down is integers. This, I really think this one does have to do with the Latin for integers, is the capital letter Z. Integers. That's all I got, Z. It's one you might have to just memorize. Z goes with integer. So 7 is an integer, negative square root of 100. I have to test your number sense here. Simplify square root, negative square root of 100, that's going to be a negative 10. And 0 goes in the integers category. You look at negative 8 over 2 and you might think, quotient, fraction. Also, simplify before you decide the smallest category that those numbers can fit into, because negative 8 over 2 equals what? Negative 4. So that can actually go beyond rational numbers down into the integers category. Whole numbers. Guesses on letters for whole numbers.
W?
Yes. By this point, we are definitely not sure. W starts to make sense here. W, whole numbers, obvious. 2, 0, 20 over 4 is equal to what? 5. And finally, natural numbers, that is an N. Natural numbers, we could put all manner of things in any of these boxes. Square root of 9 is what? 3. This type of vocabulary lesson lends itself really well to this picture display of our different subsets of numbers created by Mr. Venn. Venn diagrams.
Is that his real name?
It's John Venn.
He's lying about his name? That's identity theft. That's illegal.
John Venn, Venn diagram.
Where's the lie?
Then his name's John.
John Venn.
Last name Venn.
Then where does diagram come from?
It's a diagram.
He made up the diagram.
Oh,
And it got
I
named
thought
after
you meant
him.
his name was Venn Diagram, like that was his last name.
John.
I love it.
I
Okay,
get
this is being recorded.
Oh, wait, it is?
Yeah.
Oh my god.
I'm so
More
sorry.
of it. This is great. Okay, Venn diagram. Here we go. So the largest category here is represented by a rectangle, and all of the numbers we're talking about today are in the category of real numbers, so I'm putting the symbol R. The category that is all by its lonesome over here is the irrational numbers. So I'm just going to put the letter P over there. And then we have a larger circle with circles inside. So this is going to represent our rational numbers in its subsets. So within rational numbers we have also integers. And within even integers we have whole numbers. So if you're a whole number, you're also an integer. You're also a rational number. And finally, the smallest subset of numbers we have is the natural numbers, our counting numbers.
What are the irrational numbers? Is it like anything that's squared?
The square root of any non-perfect square, yeah. And pi. Here's some examples. We'll practice this below. these examples honestly remind me of things that you would see in your early questions on an ACT. So raise your hand if you're taking the ACT this year. All your hands. All your hands, leave them up in the air, that's you. So the school provides that for you, which is a nice savings for you.
Because they used to charge for it like $25.
It's more than, but they do charge for it. So, ACE,
Why if you if you fail it, you have to if you retake it, you have to pay for the retake.
you do. It's
I
true.
think that's dumb.
So, it's
I mean, it makes
certainly a
sense.
test that you can study for. So this content we'll be learning this year, you'll see a lot of it on the ACT as well. And it's just a good data point for colleges to understand who would be a good fit for their university. So studying is not a bad idea because so much of the content on the ACT is stuff you've learned all the way back as far as 7th grade. Okay, so taking some time and maybe finding some resources to study is typically results in a higher score because it is so predictable. But that's my little soapbox on ACT. I taught an ACT prep class. So if you want extra resources or insights, I'm glad to help you with that. Back on track for my rabbit trail. -10, we're going to write down all of the categories that -10 belongs to, starting with the smallest. It's my pro tip. Start with the smallest and work your way out. So -10, the smallest category that fits into is integers. So start with the Z, and then you can go out to the Q, and then the R. And you write all of the categories that it belongs to. Number 2, square root of 30 is 30 a perfect square. Thumbs up if you think it's a perfect square. Thumbs down if you think it is not a perfect square. 30. You all nailed it. It is not a perfect square, so therefore a square root of 30 is irrational. So that just gets the P and the R.
What's the difference between like a perfect square and an imperfect square?
So the perfect square, if you take the square root of that number, you get a whole number. Okay? So if a number times itself equals that number, it's called a perfect square.
Nothing times something, like nothing times by times itself equals 30.
I think it makes more sense.
Good, thanks. 1 7/9. Smallest category that fits into is so it's rational. That's correct. Q. Because there's a fraction there, integers. Notice if we have a fraction with integers, it has to simplify down into a positive or a negative whole number. So Q and then R.
So we can just write down R for all of them.
Yes. But like I said, I think the best way to think about these and not miss a category is to start with the smallest one that it can fit into and then work your way out. 24/8 cannot be simplified. Yeah, it's 3. That's a natural number. So then, if it's a natural number, what other categories does that fit into?
Whole integers.
Whole numbers, integers, rational numbers, and
All of them except for P.
That's right, all of them except P. If it's a counting number, that's always the case. It's a natural number. I'm going to skip 5 for now. Negative square root of 81 is 81 a perfect square. Thumbs up if you think yes, thumbs down if you think no. Yes, you guys are correct. It is a perfect square. The square root of 81 is
Negative. Oh, this one's
Yeah.
negative.
-9. And so that fits, the smallest category would be, good, integers. Integer, rational, and real. Number 7, pi minus pi.
Irrational. Oh wait, no. It would be a whole number because it's equals 0.
That's right. Woo! Why do we look at that and feel like it's irrational? Because we see the symbol pi.
Yeah.
But it's 0. You have to simplify first, and 0 fits into whole numbers. Well done, Liberty. Number 8, radical 16 over 25. So this is the fraction key. It's also the square root key on your calculators. Double check that you know where those keys are, please.
I do.
It's 4/5. So square root key is second on the next square. And then you hit 16 and fraction button 25. The fraction button has an ABC on it. Yeah.
I don't think this is right.
That is not right.
I heard it. 4/5. It's a fraction. Smallest category that fits into is what?
First.
What's the smallest category 4/5 it fits into?
Rational numbers?
Yes, rational numbers. Good. It's a fraction. Q. And then R. Number 9.15, repeating. That's right, rational. So Q and R again. I'm going to skip to number 12. Number 12 is radical 7 over radical 7. Real quick, anybody know what that equals? Put your hand up if you know.
Wait, which one?
Number 12.
I know how to solve it.
Put your hand up. Don't shout it out. Put your hand up if you know what radical 7 over radical 7 equals. Do you know what it is? 1. Any number, and you can write things down, but I don't have a guide for it. Any number divided by itself is equal to 1.
Why?
I forgot about that rule. I'm not gonna lie.
Even if it's funky, like radical 7. So this one's all of them. NWZ accepts the P. Go ahead and try number 5, 10, and 11 on your own.
Is there a way we can turn a fraction into? How do you do that on the calculator?
Turn a fraction into a decimal or decimal into a fraction? Is that the question? So if I have 4/5,
Yeah. What did you just press?
You press the second and then fraction.
so if I hit,
Second? Yeah. No, you press the second first.
so if I hit second and then the PRB button, I can translate between
I guess.
a fraction and a decimal.
Wait, how did you do
So
that?
I hit second and then the PRB button, see the F to D
Oh,
above
it.
it. So then I can switch back and forth between fractions and decimals that way.
Oops, I forgot.
You're so
I
close.
was close.
All right.
I got 1225. Oh, that's still.
Number 2.48. What did you get for that one, Tylee? Is that, what's the smallest set that belongs to? Rational? Yes. Rational is the smallest, so it's just Q and R. Lily, number 1, or 10. 109. What is the smallest set that belongs to? It is an integer, but there's an even smaller category that it belongs to. Liberty?
Whole number?
Whole number.
Oh, natural
And in
number.
fact-
Natural number. Sorry.
Natural. It is the smallest category. It fits into the natural, so then we get to write all the letters. N, W, Z, Q, R. And finally, number 11, negative 8/3.
Integer?
Not an integer. Integers are only positive and negative whole numbers. But thanks for trying.
Rational?
That's right. It's a fraction, so cute. You saw the negative sign, but that's what it was. And you thought, oh, positive and negatives.
I was looking at the negative and
Uh-huh.
I looked at.
Q and
Yeah,
R.
I'm like.
This concludes our first set of notes for the semester. Well done. Give yourselves a round of applause. Real numbers and problems.